Okay, we're continuing with the implicit differentiation. So here it says find dy dx, or the derivative by implicit differentiation. Now that is just implied. It doesn't have to say that. Once you know that you have two variables, it's always going to be implicit on there. So whether you have an x and a y, notice how the y is not y equals. Even when it's y equals, you're still doing implicit differentiation. If you have two variables or more, you're always going to have to use implicit differentiation. So even if it doesn't say it in the directions, you're still going to have to use implicit differentiation. So here's this first problem on there. So you have 1 plus x on one side, and then you have the sine, and which is the trig function, and then you have an x and a y squared being multiplied. So it's going to take a little bit of time to do this, and it's going to have quite a few of the rules that we already should know. So starting on the left-hand side, we're going to know the derivative of 1 is going to be 0 because it's a number, and then the derivative of x, because we're taking it with respect to x, that is going to be exactly the same. It's going to be 1. And then we're going to take the derivative of this side, where we're going to have the chain rule, and inside is going to be the product rule and the chain rule again. So the way that you take this derivative here is we're going to take the derivative of the outside, which is the sine. So we're going to do cosine. And then we're going to leave the inside alone. So we leave the x times y squared alone. And now we're going to chain on the derivative of the inside. So we're going to chain on here. Now it's the product rule because we have two quantities in there. So this here, we're going to take the derivative of x and leave y by itself, leave y alone. So we're going to take the derivative of x, which is just going to be 1. And then we're going to leave the y squared. And so that's going to be one part of it. And then we do the plus part. And then here, when we're looking at this, now we're going to leave the x alone, and we're going to take the derivative of the y squared. Well, in order to take the derivative of the y squared, because it's with respect to x, it's going to be a two-step. The outside function, which is just going to be times 2, and then y to the 1, and then we have to take the derivative of the inside, which is the y, so it's going to be times dy dx, which is just a derivative of the y by itself. Now here, if I leave it like that, I would be wrong, because this just says that this quantity is going to be multiplied to this quantity right here, when it's not. It's actually multiplied to the whole thing, and so we have to make sure we put parentheses around the whole thing. So in order for me to solve, I have to have dy dx, and this is where your algebra skills come into play. You should have some good algebra skills there. And so what we need to do is we need to solve for this dy dx. So the first thing you want to do is that these two quantities and this quantity is being multiplied. So I want to get rid of this quantity, and I really don't need that 0. So what it happens is going to be 1 over the cosine of xy squared. And so then that's going to equal to 1, and I don't really need to add, do the 1 there, so it's just going to be y squared plus, and then this one here, I could rearrange it. The order multiplicative rule of multiplication means that I can move them around and have x, y, so that the coefficient goes to the front, and I get the dy dx there. And then I still have to get the dy dx by itself, so I'm going to move this over. So I'm going to have 1 over the cosine of xy squared, and then this is going to move over, so it's going to be minus y squared. And we're going to get 2xy dy dx. Now, we have this on the left side and this on the right side. The dy dx is still not by itself, so what we need to do is we need to get rid of the 2xy. Now, if I do this, this is going to be really complicated if I just go division all over it and put that in the denominator. So because I already have a fraction, and you should always use that rule that if you're already a fraction, we do not divide both sides, but we actually multiply it by 1 over, we use the reciprocal. So this is going to be over 1, so those two are going to cancel, and then that's what I do on this side. I multiply this by its reciprocal, which is going to make it easier, and it's not going to be a complex fraction. And then I could just distribute this to this part, and I put this over 1. Anytime you're multiplying fractions, you put that over 1. So this here is numerator times numerator, denominator times denominator. So I am going to have 1 over 2xy cosine of xy squared And then I distribute it to that side, so it's going to be minus y squared all over 2xy on there, and that is going to be equal to dy dx. And we have the dy dx, so I'm just going to like modify it just a little bit. This one here has that in common, so I am just going to be reducing that. And so if I write it here, dy dx is going to equal to 1 over 2xy cosine of xy squared, and then minus y over 2x over 2x. And so that is going to be your answer. So that's the derivative of that problem. Looks pretty nice, huh? Okay, so let's look at this one. Um, this one here has a few things in there. Notice how it has a square root, and then inside they're being multiplied, so we have to use the product rule, and then the outside is the chain rule. Here we're going to have to use the product rule, so we're going to have quite a few steps there. So the first thing that we are going to do is I'm going to change this to xy quantity to the 1/2 so that we could work through it. And so I know that the derivative is going to come down. So I'm going to have 1/2 and then inside. So that's the derivative of the outside. The inside stays the same. And then we are going to have to the negative 1/2 because we have to subtract 1 from this and then bring that in. So that's how we get that. And then we have to chain on the derivative of the inside, but the derivative of the inside is the product rule. So we're going to have the derivative of x is 1. So derivative of x is 1. And we have the y, so we leave the y alone. And then we have the x. And we take the derivative of the y, and the derivative of the y is dy dx. Okay, my computer's being a little bit sensitive. Okay, and then we're going to set that equal to 0. The derivative of 1 is 0, and then I have to do the product rule again here. So it's going to be 0 plus, and then it's going to be the derivative of x, which is 2x. We leave the y alone, and then then we're going to leave the x alone, and we're going to take the derivative of the y, which is dy dx. So here is the derivative, but of course I can't leave it like that, and this is where the algebra comes in. I have a dy dx over here and a dy dx over there. So now the rest is just algebra manipulation to try to get one dy dx, that's all I could have, and then solve through and get it on one side and get everything else on the opposite side. So how do I do this? Well, here, this one here is going to be a negative, so that's going to, and it's a square root, so this one here is going to be 1 over 2 square root of xy, so that's what that becomes on there, and it's going to be multiplied to this side, so it's going to be times the 1 y plus x dy dx. We don't need the 0 there, so we have the 2xy plus x2 dy dx. So notice how this dy dx is inside these parentheses, so I have to get it out of the parentheses. The only way that I'm going to do it is if I distribute this to all of that. So I really don't need this one here, so I really don't need this one. So, but this here is going to be, because this is a fraction, I'm going to put all of this into a fraction. And so I am going to put this over 1 and this one here also over 1 so that I could actually distribute this to this side and that side. So I am going to get y over 2 square root of xy plus, and then I'm going to get x over 2 square root of xy. And then this one's going to have the dy dx attached to it. And then on this side, I am going to have the same thing because there's nothing to do there. And so my next goal now is that I got this out of the parentheses. So now it's a term in itself. This is a term in itself. So I'm just going to move this over, leave this one here, and I'm going to move this one over so that I could have the dy dx's on the same side. So what we're going to do is have x 2 square root of xy dy dx, and then I'm subtracting this one over to this side, so that's going to be dy dx And I'm going to move this one over to this side. So I'm taking this and moving it over to that side. I'm leaving this one on this side. And I'm going to have y over 2 square root of xy. So notice how I have the dy dx's on this side, and I have no dy dx's on that side. So we're on the right process. I'm going to move over to this side over here. And so now I could actually factor the dy dx there. So I am going to have this to be dy dx, and then inside I'm going to have x over 2 square root of xy minus x squared, and that is going to equal 2xy minus y over 2 square root of xy. So now I just have to get rid of this. And so one of the things is that if I get rid of that, the only way that I could do it is by multiplying. So I am going to get the dy dx is going to equal to 2xy minus y over 2 square root of xy all over x over 2 xy minus x squared. And that looks really ugly because you're not supposed to have a complex fraction over a complex fraction. So in order for us to do this is over 1, this is over 1. So if you notice all the denominators, this is 1, 2 square root of 2 square root of x squared, x times y, 2 times the square root of x times y. So they have a common denominator of 2 square root of x minus y. So I'm going to do that. I'm going to multiply this by 2 square root of xy over 1. And I'm going to multiply this one here also by 2xy over 1. And then you're going to distribute this to both terms. And you are going to get, if we look at it, I'm going to do that in a I'm going to leave it on there. So I'm going to have this. So this one's going to have, if you look at it, it's going to be, when I multiply numerator times numerator, I'm going to have 4xy square root of xy. And denominator to denominator is equal to 1. And then I'm going to distribute it to the second term. So it's going to be minus. But when I distribute this denominator and that numerator are the same. So they actually kind of cancel there because they have the same thing. And so now I'm just going to have over y. And that was the whole point of doing that common denominator. That's going to be the same thing here. When I distribute this over here, this part is going to cancel with this part. So we're just going to have x minus, but it doesn't cancel here because when I distribute this here, I am going to get the x squared and then times the 2 square root of xy, which we could move that 2 to the front on there. And now this is what your dy dx is actually equal to. And that looks much better than this mess. So that's the derivative there. Okay, so let's look at this problem here. Find the equation of a normal line. A normal line is a line that's perpendicular. A perpendicular line is always found by the opposite reciprocal, and so of the slope, and we want it to be at point -3, 0. So how do I find this problem? So in order for us to do this, this is the equation that's given to us on there. So if I look at this, find the equation on here, we are going to have the perpendicular. We need to find the slope at this point. And so we're going to have to take the derivative. So the first thing that we want to do is we want to have the equation. And so we know we need to have a slope and we need to have a b on there. So I need to find, because it's y equals mx plus b, so I need the m and the b. And so we know we find the m using our tangent slope on there, and then we are going to find that we have a point there so we could find what our b is. So I'm taking the derivative of e to the 2x equals to x squared minus 2x. So if I look at this, this is a derivative of e to the x. So I take the derivative of the outside function. The derivative of the outside function is e, so the derivative of e is also e. So I take e and I leave the inside alone. And then I'm going to chain on the derivative of the inside. And so that's 2. So it's going to have 2. And the derivative of y, we're going to still be doing it with the dy dx. So this one's going to be taking dy dx there because we're taking the derivative with respect to x. So that's what we have there. And then the other side is going to be 2x minus, and then again, we have the product rule, but that you have the 2, and then we're going to have the parentheses. We're leaving the x alone, and then we're taking the derivative of the x, which is 1, and we're leaving the y alone, plus, then we leave the x alone, and then we're taking the derivative of the y, which is dy dx. On there. Okay, so then we still need to find and solve dy dx. So how am I going to do that? And the way we're going to do that is notice that there's a dy dx here, there's a dy dx here, and then I have to leave everything else the same. So I need to get the dy dx's on the same side. So I need to distribute this 2 to get it by itself and not in a quantity. And then I need to get rid of the e to the 2y there. So what we're going to do is a little bit of steps at a time. So we're going to have 2xy times 2 dy dx is going to equal to 2x minus 2y minus 2x dy dx. And so we're going to get these two together on this side. And so the way that we are going to do that is just move this over. So this is a quantity, and I'm going to move that 2 here. And so we're going to say 2e to the 2y, because that's just a coefficient being multiplied. I could just move it to the front, and then that's dy dx. And then I'm going to add this to this one, since this is already a subtraction there. And then that's going to be a dy dx, and that's going to be 2x minus 2y. So notice how I have this quantity that's being multiplied. It has a dy dx. This one also has it, and then this one does not. So then we're going to move on this, and we're going to factor out a dy dx. And so we have 2e to the 2y plus the 2x is equal to 2x minus 2y. And then so we end up with dy dx is going to be 2x minus 2y divided by 2e to the 2y plus 2x. And so that is going to be the derivative. And so we want the slope there. So this is a derivative that gives us the slope of the equation there. And so what we're going to do is we're going to then put in the point there. So we're going to take this derivative and we are going to fill that in. So we're going to have the dy dx, because that's going to give us their slope. And so to simplify this, notice how they have a common of 2 and 2 there. So I am going to just say x minus y, and then e to the 2y plus x, because we could factor out a 2 from there and factor out a 2. So this is actually 2x minus y all over 2e to y plus x, and so that 2 cancels out, and that's where we get there. And much easier to calculate when I substitute the values. So this is going to be a -3, and so we're going to be able to put in those values there, and so it's going to be -3 minus 0 over e to the 2 to the 0, not 20, because you're multiplying these, and then plus a -3. So what we end up with here is going to be -3 in the numerator. E to the 0 is going to be 1. So this one here is just going to be 1 plus a -3, which is going to give you a -2. And so a negative and a negative is going to be a positive. And so we end up with the slope being 2. So that's what your m is. We found that your m is going to be 2. And so we need to, that's what we have there, but we want the perpendicular line. So we're looking for the opposite reciprocal of the slope. So the slope that we really want, the right one here, let's call this m sub 1 and then we'll call this one m sub 2, is it's going to be the negative 2/3 of it. So that's what we're really looking for. That's the slope that we're looking for on there. And so we are then going to, and it's going to go through this point, so we're going to then take y equals mx plus b equation here. And so we are going to fill this in to be 0. The slope is going to be negative 2/3, and then the x is going to be negative 3, and then we're going to solve for b. So b is going to be negative 2. So that's what we ended up having there. And so now, since we're looking for the equation of the normal line, which the normal line is the perpendicular line, and we did that by doing the opposite reciprocal of this. The equation that we get is going to be y is equal to negative 2/3, negative 2/3 x, and then minus 2. And that is what we're looking for. Okay, very good.